Greetings. We are the Group H, and our machine learning topic is building a robust model to predict the presence of PCOS. The prominents of this mini project are Aleta Allen Royce, Kang So Kevin Christian, with Ma'am Ambita as co-author of this study. For the easier viewing of this presentation, we will follow the overview of the study. We will start with introduction, methodology, feature selection, results, conclusion, and end with the recommendation. Thus, let us start with the introduction. Introduction: Polycystic ovary syndrome, or also known as PCOS, is a symptom that is commonly found in women of childbearing age. And the problem today in our society is that PCOS has been prevalent in the Philippines. Therefore, our team proposes on building a predictive model to diagnose PCOS as a preliminary diagnosis for healthcare centers with the aim of to reduce the probability of or preventing misdiagnosis, mistreatment, and treatment delay. Our team aims to build a model for diagnosing PCOS using the PCOS database from Kaggle.
The methodology of the study started with gathering of the data. The dataset from Kaggle was provided by Court Hatley. The dataset consists of 541 samples of data from female patients in India. 43 attributes were included. The data was cleaned, pre-processed, and standardized for both setups. The study was divided into two experimental setups. Setup number 1, where all features are selected. Setup number 2, most informative features are selected using feature selection method. The models tested for performance are KNN, SVM, logistic regression, random forest, and extreme gradient boosting. For the implementation part, the implementation started with an experimental setup. In this case, we proceed without feature selection. We will compare the best performing models in both setups to determine if all features can predict efficiently, then selecting only the best features. The second setup includes feature selection method, specifically the select k-best method. The models are fitted with the data and made predictions and evaluated its performances. In the last phase, we determined the correlations among the features and found out that two pairs of features have strong positive correlations. We also did the comparative analysis of the performance based on F1 scores for models in both setups.
For results, there's a strong positive correlation between weight and BMI and the follicle numbers of the left and right ovaries of females. The F1 score helped determine the best model between the two classifiers, namely random forest and support vector machine, where 0.825 is the F1 score for RF and 0.86 for that of SVM. Hence, the support vector machine model is selected to determine the absence or presence of PCOS. For conclusion, by the end of this study, we proposed a model for predicting the presence of PCOS in females. It was shown experimentally that most models work efficiently in predicting PCOS. However, SVM was more efficient with an accuracy of 92% and an F1 score of 86% in predicting the presence of PCOS. In future works, maybe we can try other machine learning algorithms or verifying the robustness of our model by testing it with different feature selection methods. We can also collect more diverse and complex data and use different datasets to see if it improves model performance.
These are the references included in our study. And this marks the end of our presentation. Thank you for listening.